In college algebra, we moved up to 3 variable systems of equations. So anytime you see a 3 variable coordinate, it's alphabetical. It's X, Y, Z. And on number 1 here, when you're trying to determine if that's a solution, you just plug in. So we're going to plug in -1, 2, and -2 in place of X, Y, and Z and see if it equals 9. So we're going to go -1 plus 2 times 2 minus 3 times -2. So we get -1 plus 4 plus 6, and it does look like it equals 9. Now all 3 have to give us true statements. So we're going to go 2 times -1 minus parenthesis 2 plus 2 times -2. And that equals -8. So simplify, and it looks like it checks out. -8 equals -8. Let's check the last equation. Plug in a -1. Be really careful with those negatives. Plug in a 2. Plug in a -2. And we get 15 equals 15. Yes, that is a solution. All right, let's move on to a harder problem. We need to solve a system with 3 variables. It's a little tricky to do, but we can do it. I made it into a 4-step process. Step number 1, pick 1 variable to cancel. Using 2 equations. So let's make Z cancel. Let's make Z cancel. You could pick any of the 3 letters. All the classes are picking different letters. With equation 1 and 2. So we take equation 1, and I see we have a -4z. I look at equation 2, I see we have a 2z. We could easily multiply this equation by 2, and that'll give us 4z for the z term, and the z's will cancel. I'm going to leave the first equation alone. And the second equation, I double everything. And this right here is the whole reason why we did what we just did. Because whenever I add these 2 equations to each other, we get 11x, 4y, the z's cancel, and -3. So we'll use that equation in just a minute. Second, we need to make the same variable cancel. Using 2 different equations from earlier. I guess I shouldn't abbreviate, huh? So we're going to make z cancel again, only I'm going to use equation 2 and 3. So I'm looking at the 2z and the 3z, and I know that they have a common multiple of 6. So you got to be really careful how you write right here. We're ignoring this 2 right here. We're done with that 2. But I'm taking the printed equation, and I'm going to multiply that equation by 3. Oops. Then I'm going to take the third equation and multiply by -2. And you'll see why in just a moment, if you don't see why yet. So when I do that, I get, whoops, let's draw a better arrow. We get 9x plus 9y plus 6z equals -9. We get 4x minus 10y minus 6z and -6. And this is what we were hoping would happen. When we add these two equations to each other, we get 13x plus, whoops, almost messed up there, minus y. The z's cancel, -15. All right, now I have two new equations. It's almost like a new system. So step 3, we're almost to the end. Hang in there. Make a different variable cancel. Using the two new equations. Now I'm looking at the 4y and the -y and canceling canceling out the y. When I see 11x and 13x, that would not be any fun to find a common multiple. So let's compare 4y and -y, and it would be very easy to just multiply the blue equation by 4. So this equation I'm going to leave alone and just copy. And this equation I'm going to multiply by 4. So I end up getting 11x plus 4y equals -3. 52x, had to stop and think for a second there, equals -60. And look at that, that's a really good sign that we did it right. We get 63x, those y's cancel, equals -63. That means x is -1. Very good sign that we did it right. Oops, wrong button. Now let's do the last step, the easiest step, back substitute. To find remaining variables. So I'm going to plug -1 into either the blue equation or the red equation. Doesn't matter which, I will get the right y value. So I'm going to plug into the blue equation, and we have 13 -1 minus y equals -15. Y equals -2, which means y is +2. So now we have a second answer. We need one more answer. We need to plug -1 and 2 into one of the printed equations. So I'm out of room. Let's do that at the very top. 5 -1 minus 2 times 2 minus 4z equals 3. So we get -5 minus 4 add 9 to both sides and we get 12, and z ends up equaling -3. All right, I hope that made sense. I will see y'all later. Bye.